We're here at this large kidney, and of course we talked about that on our previous YouTube, but I want to draw your attention here once again to the pyramids. So these are the pyramids right here, and then these little white dots are the glomeruli. The tubes, of course, represent the various tubes that I'm going to be talking about in just a few minutes. But notice that this section here is the same as this structure here. So we've sort of enlarged the structure for you. So now since we have this enlarged structure, let's go to what we refer to as the nephron. The nephron is a combination of the renal corpuscle, which is the glomerulus, and the Bowman's capsule. Now, if we can switch over here real quick, this is the glomerulus. The glomerulus is essentially a collective of fenestrated capillaries that are the blood filters. The epithelial cells that are responsible for making these capillaries are also covered by specialized filtering cells called podocytes, and that's what these white structures are. So in effect, the fluid coming from the blood is going to be water, it's going to be nutrients, it's going to be ions, and all that kind of filters into this region here, which is the capsular space of the glomerular capsule, or it's also known as the Bowman's capsule. That fluid then is going to drain into a tube, and so we're going to look at that right here. Alright, so this is what we saw, right? This is the glomerulus. That is the glomerular capsule, and it drains into a tube called the proximal convoluted tubule. In the proximal convoluted tubule, we're going to be reabsorbing the nutrients that we just lost, that's glucose and amino acids. We're also going to absorb the lion's share of the water that we've lost. If we didn't reabsorb most of the water in the kidney, actually, we'd be urinating about 45 gallons of water a day, so that's not a good thing. So it's a good thing that we have the glomerulus and the nephron, which is essentially this entire structure here is the functional and structural unit of the kidney. So the proximal convoluted tubule is all about reabsorption. And if we take a look here at this model once again, you can see how fuzzy the inside of that tube is. That represents the microvilli of these cuboidal cells that make the proximal convoluted tubule. Okay, back to our big model. So the proximal convoluted tubule gives rise to the loop of Henle. And you can appreciate how the loop of Henle drops down from the renal cortex down into the medulla. The renal medulla is this nice salty area. As it drops down into the salty medulla, it winds up losing water to the medulla. Now this water is ultimately recollected in the vasa recta, which is a capillary field that surrounds the loop of Henle. As we get down here though and start going up, we're no longer losing water, but we're losing salt. So sodium chloride essentially is the source of the salt, the salty renal medulla. So we go up and up and up and up and up through the medulla into the cortex again, and we wind up going into another tube called the distal convoluted tubule. Notice that the distal convoluted tubule passes very close to the glomerulus. It is here where we have regulatory mechanisms for the blood pressure within the glomerulus, and I'll get to that in just a moment. But anyway, this is referred to as the distal convoluted tubule. The distal convoluted tubule is responsible for mineral balance. So we decide in this region whether we're going to save sodium at the expense of potassium or vice versa, and also we're going to try to expel extra hydrogens if we can. So off we go into this next drainage region, which is the collecting duct. Collecting duct drops all the way down into the medulla, and ultimately at the base of the pyramid, if we go back to here, you can see that we're in the minor calyx. And so the fluid, which is now urine, is going to be draining then into the minor calyx, ultimately from the calyxes then into the pelvis and then into your urethra. Okay, let's go back here one more time and take a look at this tube. This tube is the distal convoluted tubule. These larger cells here kind of in a row, I think the artist is trying to represent the macula densa. And the macula densa is a regulatory structure for determining the blood flow through the kidney, hence the blood pressure of the kidney.